All right, let's dive right into one of the biggest questions you can possibly ask. What if the very stage our lives play out on, space and time, isn't actually real? What if the whole thing is just an illusion?
Yeah, this is the big one, the idea we're going to unpack today. It really forces you to rethink everything. I mean, everything we do, everything we experience, seems to happen in a place and over a period of time. But what if that's just our human way of seeing things? So you've got this huge contrast, right? On one hand, there's the world we see every day. Feels solid, it's predictable. If I drop a ball, I'm pretty sure I know where it's going to land. But modern physics? It paints a totally different picture. It says that at the deepest, most fundamental level, reality is just chaotic, disconnected, and, well, really, uncertain.
To really get our heads around this, we need to go on a journey. We're going to zoom way, way in. I'm talking past what any microscope could ever see, down to this submicroscopic level where all the rules we think we know just stop working.
And here's where it gets absolutely wild. The very ideas of space and time, which feel so concrete and absolute to us, they actually stop having any meaning at this tiny, tiny scale. They just vanish.
Okay, so if space and time disappear, what's left? What are we even talking about? Well, physicists have a name for it: quantum foam. Let's take a second and break down what that actually means and where it comes from.
It all really starts with Heisenberg's famous uncertainty principle. Now, you might have heard about it with, position and speed, but it also works for energy and time. What that means is, for super, super short moments, energy can just fluctuate like crazy, popping in and out of nowhere. It creates this constant, chaotic fizz at the very bottom layer of reality.
So here's the really crucial part. That constant fizz of energy isn't just happening in space-time, it is space-time. It takes that smooth, nice, continuous sheet of reality we all picture in our heads and just churns it into something violent, unpredictable, and constantly roiling. And that is what scientists mean when they talk about quantum foam. It's this idea that if you could somehow zoom in and look at space-time at the smallest possible level, it wouldn't be a neat little grid. It'd be this bubbling, fluctuating, constantly changing mess where all our normal ideas of here or there or before and after just completely fall apart.
And this has a couple of massive consequences. First, the whole idea of a smooth, connected space gets thrown out the window. Like, is this point really next to that one? At this scale, who knows? And second, the orderly sequence of time, past, present, future, it just breaks down. The concepts of before and after become totally meaningless.
This incredibly bizarre picture of reality led one of the greatest minds ever, Albert Einstein, to totally rethink what space and time even are. He looked at all this strange physics and took a huge philosophical leap.
He realized that, hey, if space and time aren't fundamental parts of the universe itself, then they have to be something else. He was actually inspired by the philosopher Immanuel Kant, and his conclusion really turns our whole view of the world completely inside out.
And here it is, this is really the heart of this whole thing. Einstein said, time and space are modes by which we think and not conditions in which we live. Just let that sink in for a second. He's not saying they're physical places. He's saying they are tools inside our mind. So let's unpack that. We all have this gut feeling that space and time are like a giant box, right? A container that the whole universe just sits inside. But Einstein is saying the exact opposite. There is no box. There's just reality. And our brains have evolved to use the ideas of space and time as a kind of operating system, a way to make sense of all the information. They're just how we organize everything. So what on earth does this mean for science? I mean, if space and time aren't the starting point, that completely changes the ultimate goal of all of physics.
This is a huge deal. For centuries, physicists have just assumed space and time are the given stage where everything happens. But if Einstein's right, any true theory of everything, that single theory to explain all of reality, well, it can't just take them for granted. Space-time has to be an output of the theory, not an input. It's a complete paradigm shift. The old way was you take space and time, you feed them into your equations, and you try to explain the universe. The new, much, much harder goal is to start with something more fundamental, we don't even know what it is yet, and have space and time emerge from that theory. We have to build them from scratch. And that leaves us right here with what is maybe the biggest question in all of science. If the world isn't built on a foundation of space and time, then what is it built on? What are the true, fundamental building blocks of everything? The things from which this grand illusion of our world emerges? That's the challenge, and it's what the next generation of physics is trying to figure out.